Okay, part 4. This is where we go into what is an LED. Okay, so you might be saying to yourself, but I know what an LED is. I've seen them, I've used them, but if that's the case, why do I get so many questions on people asking me, how does it work? Why does it work? What do I have to do? How do I do it? There's a lot of information on LEDs online as well, but there's also a lot of people selling their own products. Okay, so an LED is a light emitting diode. We get that. We spoke about that previously. It has an anode and a cathode. It's generated through heat. It has a dye which is a luminous dye. It heats that up and it creates light. And it's the quality, it's how it's designed. They're all DC. They do not make an AC LED because it's a diode, and a diode will only let things operate one way. So, some examples of it. So, when we were looking here previously, this is the larger one on the left. So when we look at this, when you look at your paperwork, we look here. This is what we're talking about with them. Okay, so these are the original. They were indicators. They were used in switchboards. They were used to actually indicate motors running, power on, power off, whatever it might be. But they were used as indicators. They had a little plastic clip that you used to drill a hole, slide them through, and you could hook them up behind. What it meant was I wasn't using big indicator lights, I wasn't using big bulbs or anything like that, because the intensity of the LED was good enough that you could see it from a distance. So we didn't have to keep replacing bulbs, testing bulbs and things like that. So what does it mean? Well, when we look at these LEDs here, we have an epoxy lens or a case. Inside there, and you can see it going from the anode to the cathode, or there's a wire bond that goes across to the anvil, from the post to the anvil. Then you've got your reflective cavity, and you've got your semiconductor die. Okay, what happens is there's an air gap. So we've got a positive and negative. If you ever get your battery, 2 wires off your battery and touch them together, you get one massive spark. So what we're saying here now is, because those two, the anode and the cathode, don't actually touch, it creates heat between the two because there's a small air gap in the design, but there is that wire bond that goes across into the semiconductor die, which then causes a reaction because you've got the positive wire coming from the anode, and you've got the cathode where all the semiconductor die is, and between the two of them, it lights up. So as soon as you put power on, it lights up. Okay, so that's how they work. And that does not change even today into the big square ones, into everything, the SMDs, the chip on board, the multiple chips on board. The principle of the diode is exactly the same. These are some of the old styles and shapes. There's one there with 3 legs. No, it didn't get one by accident, an extra one. But what that one is if something's running, it'll go one colour, but if something stops, it'll go to another colour. So that's that was the first dual colour LED. All right, but the principle of every one of those, even to the ones that we use today, is exactly the same. And we have a diagram that actually proves that. What we've got now on the screen and in your books that you'll see is this is actually an SMD. So this is a current day one, and you can see that nothing's really changed. We've still got the anvil, we've still got the post, we've still got the wire, and we've got the wire bond, and the whole process of the LED still operates in the same way as the original one did when we were looking at these. Same principle, only now it's flat. And the reason it's flat means that that little pot, that reflective cavity, is now larger and actually produces a greater light output. And that's how we get the 120 degrees also, whereas the other one is just round and it just goes everywhere. This now is 120 degrees and goes straight out like that. Okay, so moving on from that, also in your book you'll notice that there is some numbers here which they indicate the size of the LED strips. It's always XY axis, but those are the sizes that are currently available in LED chips. There's always 4 numbers, and if it's 5050, that means it's 5 millimeters by 5 millimeters. If it's 28 by 28 or 28 by 30, it's 2.8 millimeters by 3 millimeters. That's the size of the LED chips, and that's here in your book. All right, so let's move on.